I want to ask you something, and I want you to actually sit with this question, not just skim past it. Every person you have ever loved, every person who has ever walked this earth has died or will die. Every single one. Your grandparents, your parents, eventually, you. And for as long as humans have existed, we have asked the same question. What happens after? Now, religions have their answers. Philosophers have their answers. And for most of human history, that is where the conversation stopped. But today, I want to take that question somewhere it rarely goes. I want to ask it to physics. Because Richard Feynman, one of the greatest physicists who ever lived, was asked this question directly in an interview near the end of his life. And his answer was not what most people expected. It was not comforting in the traditional sense. It was not religious. It was not dismissive either. It was something far more interesting than either of those things. It was honest. And by the end of this video, I think you will find, as I did, that the honest physics answer to this question is more profound, more beautiful, and more surprising than almost anything religion or philosophy has ever offered. Let us find out what physics actually says. G'day and welcome back to Curious Physics AU, the channel where we ask the universe's biggest questions and follow the physics wherever it leads, even when it leads somewhere deeply personal. I am Abdullah, and today we are doing something I have wanted to do for a long time on this channel. We are going to explore what physics, genuinely, rigorously, honestly, has to say about life after death. Now, I want to be clear about something before we start. This video is not here to tell you what to believe. It is not going to attack anyone's faith or philosophy, and it is not going to pretend physics has all the answers because it does not. What it is going to do is take the question seriously. Apply the actual laws of physics, follow the evidence, and arrive at conclusions that I think will genuinely surprise you, because Feynman always said, the first principle is that you must not fool yourself, and you are the easiest person to fool. So today, no fooling, just physics. Let us go. Let us start with Feynman himself, because his actual words on this subject are remarkable. In a 1988 interview, just weeks before he passed away from cancer, Feynman was asked whether he believed in an afterlife. He said, and I am paraphrasing carefully here because his exact words deserve respect. He said he preferred to live with not knowing, that the idea of an afterlife felt like wishful thinking to him, that he had spent his life following evidence, and the evidence did not clearly point to personal survival after death. But, and this is the crucial part, he also said something else. He said he found genuine comfort in the fact that the atoms that make up his body had existed for billions of years before him, and would exist for billions of years after. That he was, in a very real sense, borrowing matter from the universe temporarily. And then he said something that has stayed with me ever since. He said, what is so terrible about not knowing? That is pure Feynman, not dismissing the question, not pretending to have answers he did not have, but finding something, not just tolerable, but actually beautiful in the uncertainty itself. So let us take his framework and run with it. Let us ask, what do the laws of physics tell us about what happens after death? Starting with the most fundamental law in all of science. The first law of thermodynamics, the law of conservation of energy. Energy cannot be created. Energy cannot be destroyed. Energy can only be transformed from one form to another. This is not a theory. This is not a hypothesis. This is one of the most rigorously tested and verified principles in all of science. Every experiment ever conducted, every observation ever made is consistent with this law. Energy is conserved, always, without exception. Now, what is your body? At its most fundamental level, your body is energy, organized into matter, shaped by billions of years of biological evolution into an extraordinarily complex, self-aware system. The chemical energy in the food you eat, the electrical energy in your neural signals, the thermal energy your body constantly radiates, the mechanical energy of your heartbeat and movement. Every joule of energy that flows through your body during your lifetime came from somewhere, and when you die, every joule goes somewhere. Here is a concrete Australian example. Think about the energy in a eucalyptus tree in the bush outside Canberra. That tree absorbed sunlight, electromagnetic energy from a star 150 million kilometers away. It converted that light into chemical energy stored in leaves and wood. A possum eats those leaves. The chemical energy becomes part of the possum, powering its muscles, its heartbeat, its tiny possum brain. The possum dies, its body decomposes. The chemical energy in its tissues is released, taken up by soil bacteria, by fungi, by the next generation of plants. That same energy, ultimately traceable back to sunlight, cycles and transforms continuously. Nothing is lost, nothing disappears, it just changes form. Your body follows the same law. After death, the energy that organized and animated you does not vanish. It transforms, it disperses, it joins the vast, continuous flow of energy that has been cycling through this planet, this solar system, this galaxy, for billions of years. Is that life after death? Not in the personal, conscious sense most people mean when they ask the question, but it is something real. Something physics can actually point to and say, yeah, this is true. Your energy does not end, it transforms. Now, here is where it gets genuinely fascinating. And this is territory that even many physicists find deeply confronting. Information in modern physics, particularly in quantum mechanics and black hole physics, information has a special status. There is a principle, not universally agreed upon, but increasingly supported, called the conservation of information. The idea is this. In a closed quantum system, information is never truly destroyed. It may become scrambled, dispersed, extraordinarily difficult to recover, but the information itself, the precise quantum state of every particle, is in principle preserved. Stephen Hawking spent decades arguing that black holes destroy information, that matter falling into a black hole takes its information with it permanently. Most physicists now believe he was wrong. That information is preserved, encoded in the subtle quantum correlations of the radiation the black hole emits. Now, why does this matter for our question today? Because you are information. Every atom in your body, every neural connection in your brain, every memory, every personality trait, every fear and joy and curiosity, at the quantum level, is a specific arrangement of particles in specific quantum states. That is information. Extraordinarily complex, extraordinarily specific, but information. And if the conservation of information principle holds, then in some sense, the precise quantum information that constitutes you is never destroyed. It becomes unimaginably scrambled, dispersed across the environment, impossible to recover in any practical sense. But destroyed? The physics is not clear that it is. Now, I want to be very careful here. This is not saying your consciousness survives, your memories, your sense of self. Those are almost certainly gone. What it is saying is that the fundamental quantum information that described you continues to exist in the universe, in a form so dispersed as to be unrecoverable, but present. The universe remembers you, not consciously, not personally, but mathematically, physically, at the deepest level of reality. That is not nothing. Now we need to confront the hardest question inside this question. What is consciousness, and what happens to it? This is, genuinely, one of the most unsolved problems in all of science. Philosophers call it the hard problem of consciousness. We can describe the neural correlates of consciousness. We can map which brain regions activate during different experiences. We can measure the electrical activity of a thinking, feeling brain. But explaining why any of that physical activity gives rise to subjective experience, to the feeling of what it is like to be you, to the redness of red, the pain of pain, the joy of joy, that we cannot do. Not yet. Possibly not ever with our current frameworks. Feynman was honest about this. He said consciousness was one of the things he found genuinely mysterious, not in a supernatural sense, but in the sense that our physics toolkit did not yet have the right concepts to grab onto it. Now, there are some serious physicists who have proposed quantum mechanical theories of consciousness. Roger Penrose and Stuart Hameroff proposed the orchestrated objective reduction theory, suggesting consciousness arises from quantum computations in structures inside neurons called microtubules. This is genuinely controversial. Most neuroscientists are skeptical, but it has not been definitively ruled out. If consciousness has a quantum mechanical basis, then the conservation of information principle becomes even more relevant to our question. Here is what we can say honestly. We do not know what consciousness is at the fundamental level. We do not know whether it is purely a product of the brain's classical information processing, or whether it involves quantum effects. We do not know whether it could, in principle, survive the death of the brain. Physics does not currently give us a definitive answer, and as Feynman would remind us, that is okay. Not knowing is not failure. Not knowing is the beginning of every great discovery. Let us talk about something physics can tell us with complete confidence, something that I find genuinely moving every time I think about it. Your atoms, your body contains roughly 7 billion atoms. That is a 7 followed by 27 zeros, an almost incomprehensible number. And every single one of those atoms is ancient. The hydrogen atoms in your body, the most abundant element in you, were forged in the Big Bang itself, 13.8 billion years ago. They're as old as the universe. The carbon atoms in your DNA, the atoms that carry your genetic information, were synthesized inside a star that lived and died billions of years before our sun even formed. That star exploded in a supernova, and the carbon it created drifted through space for billions of years, eventually becoming part of the dust cloud that formed our solar system, our Earth, you, the iron in your blood, forged in the core of a massive star in the final moments before it exploded. You are, quite literally, made of stardust. That is not a metaphor. That is chemistry. That is astrophysics. That is fact. Now, after you die, those atoms do not go anywhere. They disperse. They get taken up by soil, by plants, by other animals, by the ocean, by the atmosphere. The atoms that are currently you have been part of countless other living things before you. They will be part of countless living things after you. Some of the atoms in your left hand right now may once have been part of a dinosaur, part of an ancient rainforest, part of a fish in a Devonian sea 400 million years ago. And after you, those same atoms will continue their extraordinary journey through the biosphere, through the geosphere. Eventually, billions of years from now, back into a star. When Feynman said he found comfort in the fact that his atoms had existed for billions of years before him and would exist for billions of years after, this is what he meant. Your atoms are immortal, and they were never truly yours to begin with. You are the universe, briefly, looking at itself. Now, here is a perspective on death that physics offers, and that I think is genuinely profound. Death is not a flaw in the universe, it is a thermodynamic necessity. Remember the second law of thermodynamics. Entropy always increases in a closed system. The universe trends towards disorder, towards equilibrium, towards the spreading out of energy. Life, as we discussed in our previous video, is a pocket of extraordinarily low entropy, maintained by constantly consuming energy and expelling waste heat. But here is the crucial insight. Life as a process on Earth is only possible because of death and recycling. If nothing ever died, the atoms and molecules essential for life would become locked up in the bodies of living things. The carbon cycle would stop, the nitrogen cycle would stop, the phosphorus cycle would stop. The extraordinary complexity of Earth's biosphere, the rainforests, the coral reefs, the grasslands, the oceans teeming with life, all of it depends on the continuous cycling of matter through living and dying organisms. Death is not the enemy of life. Death is what makes life possible, what makes new life possible. Every atom that is released when a living thing dies becomes available for the next generation of life. There is an Aboriginal Australian concept, held by many First Nations communities across this continent, of country as a living, breathing, cycling system, of ancestors remaining present in the land, in the water, in the sky. Physics does not validate the spiritual dimensions of that belief. That is not physics territory. But physics does validate something in the underlying intuition, that death is not separation from the world, it is a return to it, a dissolution back into the cycling systems that make all life possible. Science and ancient wisdom, arriving at something similar from completely different directions. That is worth sitting with. I want to address this directly, because it is the question underneath all the other questions. Is there a soul? Does some non-physical aspect of you survive death? And I want to be completely honest with you about what physics can and cannot say here. Physics, as it currently stands, finds no evidence for any non physical component to human consciousness or identity. Every measurement we have ever made of the human brain, every observation of how damage to the brain changes personality, memory, and consciousness, is consistent with the view that mind is what the brain does. When the brain stops, the evidence strongly suggests that consciousness stops with it. That is the honest physics position. However, and this is equally important, absence of evidence is not evidence of absence. Physics has been wrong before, spectacularly wrong. In 1900, leading physicists believed classical mechanics described reality completely. Within 30 years, quantum mechanics had revealed a layer of reality so strange and counterintuitive that it rewrote everything. We do not have a complete theory of consciousness. We do not have a complete theory of quantum gravity. There are aspects of reality, dark energy, dark matter, the measurement problem in quantum mechanics, that remain genuinely unresolved. Is there room within those gaps for something like a soul? Physics cannot say with certainty that there is not. What physics can say is that there is currently no positive evidence for one, no measurement, no observation, no reproducible experiment. Feynman's approach was always follow the evidence. Hold your beliefs lightly. Be willing to be wrong. On the question of the soul, physics holds its hands up honestly and says, we do not know. And anyone who tells you they do, on either side of that argument, is going beyond what the evidence supports. So, after all of that, what is physics' surprising answer to the question of life after death? It is not the answer of religion. It does not promise personal survival. It does not offer heaven or reincarnation or reunion with loved ones. But it offers something that I think, if you really sit with it, is genuinely extraordinary. Physics says your energy is conserved. Every joule that animated you continues in the universe. Your information is, in principle, preserved at the quantum level. The universe carries a record of you that entropy makes inaccessible but cannot fully erase. Your atoms are ancient and immortal. They were part of stars and oceans and forests and creatures before you, and will be again long after. Your death makes new life possible. You are not separate from the living world. You are part of its continuous cycling, its ongoing story, and the consciousness that asks these questions, whatever it fundamentally is the universe becoming aware of itself for a brief, extraordinary moment through you. Feynman, facing his own death, said he did not need the comfort of an afterlife to find meaning. He found meaning in having understood some beautiful things about the universe, in having taught others to see them too, in having loved and been loved. He said the tragedy was not death. The tragedy would have been to have never truly lived, never truly wondered, never truly looked. I find that, honestly, more comforting than most of the alternatives, not because it is what I want to be true, but because it might actually be true. And that, as Feynman would say, is worth something. So let us bring it all together. Physics does not confirm a traditional afterlife. It does not confirm a soul in the supernatural sense, but it does offer something remarkable in return for that honesty. Conservation of energy. Your energy does not end, it transforms. Conservation of information. The universe carries a quantum record of you. The immortality of atoms. Your matter has been part of this universe for billions of years and will continue to be. And the thermodynamic necessity of death, which makes all new life possible. The physics answer to life after death is not a consolation prize. It is something genuinely worth understanding, worth sitting with, worth sharing. If this video made you think, genuinely think, about something you have maybe never looked at through a physics lens before, please smash that subscribe button and join the Curious Physics AU family. This is exactly the kind of video I love making for you. New videos every week. Leave a comment below. What do you think happens after death? Has physics changed how you think about it? I genuinely want to know. Every comment gets read. Share this with someone you love, not because it has easy answers, but because the questions are worth asking together, and I will catch you in the next one.